And this is pretty much a little math problem you're going to have to do. And don't worry, it's not bad. And there's a little bit of dark humor in it. So when you're done, I want you to switch the papers. And I want you to grade each other in the following way. Assign 0 if you think it's completely wrong or there's nothing on the paper. Assign 1 if you think it's like, I'm on the right track, but the person might still end up needing to borrow some money over the summer. And 2 if it's completely right, if you think it's completely right. So just 0, 1, and 2.
But what if I'm wrong?
Well,
See?
And you have to explain yourself every place where you think the person made a mistake. So write down an explanation if you think that they made a mistake and why you think that's a mistake.
I thought it was left over. I have a 1 point. What are you going to give me? Do what I did. So I'll out of 2. Of course not. We don't know. Oh, thank you. You're very generous. Because I'm a scientist, right? I work with numbers, like not complicated numbers.
What's the first thing that we try to teach students in science class? There's many different ways you can teach or do the same problem. Do they listen to us?
No.
But when you were looking at each other's papers, like, oh, I could have done it this way. Oh, I could have done it that way. And I'm sure if we collect all the papers, we can find at least 5 or 6 different ways that people were doing the budgeting. And if I try to tell students, oh, you can solve this problem 5 different ways, which way would they try to do it? Yes? However textbook does it, or the very first one I showed them. Whether or not they understand it. So what's the second thing that we have a big problem in science classes? Getting students to really understand what's happening instead of just regurgitating all the formulas. And when I forced you to actually grade each other, did you really have to understand the problem? Does it force you to understand the problem? And as I said, and the final thing that I found that this kind of approach helps with is the formula mining technique. And do you guys know what I mean by that? It's like you see some whatever letter that represents whatever in a book, and you go thumb through the book and look for the formula with that letter again in it. And you're going to use that formula whether or not it actually the letter represents the same thing. Like for example, T in physics can represent time, it can represent period, it can represent temperature. So you get frequently people substituting formulas for temperature into the formulas for period. It's because they're just thumbing through the book, finding. And doing this exercise actually forces them to evaluate whether or not their peer used the right formula. How many of you remember formulas from when you were in school? But how many of you, if you understand something, how many of you know which book to go back to look for formulas? Exactly, because you understand what's going on, and you know, okay, I know what's going on, I know where to go look for it, or I don't know if the formula has a squared or like a cubed, or if it has like 1/2, or it has pi in front of it. It doesn't matter. What matters is that you understand physically what's happening in your system. And having students do this exercise is doing exactly the same thing. It's detaching them from just chugging through the formulas, and it's forcing them to understand real physical concepts that we're trying to teach them.